My logo represents a fountain pen, which is my client's product. Now we start with a1x and then absolute the function, flipping the negative part of the graph above the x-axis. We then restrict the graph with a domain between -1 and 1 with the range found by summing the domain's x values, getting a range of between 0 and 1. We then reciprocate this first graph. Now reciprocate graphs intersect the original graph at y equals plus minus 1. Y value is bigger in magnitude than plus minus 1 in the original graph becomes smaller, while value is less in magnitude than plus minus 1 become bigger. Now x-intercept such as x equals 0 in this case becomes a vertical asymptote. This results in a hyperbola with both branches above the x-axis. Now we'll restrict the domain to -1, -half, and a half, and 1, preventing the graph from rising too drastically towards the aforementioned asymptote. And then we then sub the domain's x values, getting a range of between 1 and 2. For these straight lines, I'll discuss any missing domains and ranges later. Now here we have b2x equals 83 on 32. The range is just y equals 83 on 32, since this is just a horizontal line. Here we have two straight lines that form a cross for the pen to strike at, and another one for logo aesthetics. Here we have a composite function of the inverse cosine and absolute value graph. The absolute value in the inverse cosine flips everything on the right of the y-axis to the left of it. We then multiply this by 5, shift it up by 2 to make sure it touches exactly a free x function or the neck of the pen. These points of intersections end up being -half and half for the x value, forming our domain. By inspection, the maximum range can be found by finding the y-intercept of the function, getting a range of between 2 and 5 pi plus 4 all over 2. Here's the inequality of an inverse graph where at x equals half, y is exactly 2, allowing f2x and a3x to touch exactly at -half 2 and half 2, whose points also form the domain of the inequality. This circle relation has been scaled down by 16 times and moved up by 1 unit, and we say it's all less or equal to 1/16 to create this inequality. Here we use the square root function of an absolute value, resulting in a typical square root graph that's also reflected by the y-axis. The inequality just shades the area bound by the absolute functions and the square root of said function. Now we equate the absolute and square root function to find their points of intercept and domains. Solving them leads to a domain between -1 and 1, which can be subbed into either function to get a range of 0 to 1. Here is a dilated cubic that's absolute. The domain is between -3 and 3 with a range between 0 and 9. This creates an outline which can be dotted from Desmos' setting as if the pen was striking hard and fast. Here we have two inverse or horizontal parabolas creating an oval shape for the logo. We equate each quadratic to the aforementioned straight lines for their domains, which is both between 5 minus square root of 65 and 5 plus square root of 65, while their range is identical but divided by 20. Now for the left and right parabola, x is less or greater than 0 respectively, to stop either graph from continuing indefinitely. A range is needed so the parabolas don't cut the fountain pen tip. Now the max range is found by equating all the parabolas to y equals -x or x respectively. The minimum range is just the y-intercept of one of the parabolas, resulting in a range as shown here for both parabolas. Now we add j2 of x an absolute function and j4 of x as sine inverse function of another absolute function, resulting in a steeper function similar to that of j6 of x. Now, by letting the constant in this version be c and summing a y-intercept of 5 pi plus 4 over 2, we solve for c, which is 3 pi plus 2. We add this to j5x to get j6 of x, ensuring that this function touches the y-intercept of e3 of x function. Domain-wise, this addition of ordinates is simply just the inverse sine graph that's been shifted to the right and then reflected across the y-axis, meaning the domain instead of 0 and 2 is in fact -2 and 2. Then we can sub these values as well as 0 to get a range as shown here. This function multiplies an absolute function with a parabola to get k4 of x. Now by letting c represent a constant in k for x and equating it to y equals 83 on 32, we can solve for c, which is 6.5. Now we add this to k4 of x to get k5 of x here as shown. From this, we see the max range for dy1 and k5 of x is 6.5. For the minimum range, both graphs pass by y equals 83 on 32, the lowest y value in this section. Consequently, the range for dy1 and k5 of x is between 83 on 32 and 6.5. Lastly, we equate k5 of x to y equals 83 on 32, or b2 of x, getting points of intersections at -1/4 and 1/4, representing the domains for both functions. And there we have it, we've just created the logo for the pen company.